exciting show tonight. We are in Albuquerque at Teslatech, and today we are diving into the mind of a man who's been chasing one of the biggest cosmic secrets of all time: how to pull unlimited energy straight from the vacuum of space. We have Morray B King. He's an engineer, he's a systems thinker, and honestly, he's a bit of a rebel scientist. And he spent decades decoding zero point energy, the hidden ocean of power that mainstream science barely wants to talk about or acknowledge. And this is the guy behind the books like Tapping the Zero Point Energy and Quest for Zero Point Energy, where he lays out how vortices, water, and plasma can open the door to free energy technology. And he's been out here at Tesla Tech conferences and beyond, showing us that nature already has the blueprints for the next energy revolution, and we just need the courage to use them. And I was just having a great conversation with him outside, and his energy levels are amazing, and it's just his attitude and energy is infectious. And I had mentioned like how the cerebral spinal fluid spins like two streams around a third stream, and the heart as well. And his eyes really like started twinkling, and it was right. Yeah. And so it's such an honor to have you. And it's just, thank you so much for being here, Maury. And yeah, take it away.
True legend right here. 40 years of Tesla Tech, essentially. 4 full decades. Same age as me, this guy has been presenting and working on ZPE. It is Mr. ZPE himself.
So I guess I'll tell you about my history because
Please.
I was just a normal student. Later, I think the professors, after I got into this, called me AB normal. So I suppose that's because I was getting A's and B's in my classes. So but what happened? What happened to me? So I'm an electrical engineer, and I'm in the graduate program of systems engineering, and I had the misfortune to pick up a book on, I think it was Beyond Earth. There's just a UFO book, and I intended it's just fun science fiction type reading, right, just for fun. And what intrigued me was actually the witnesses, right, the airline pilots, the police, right, people that were smeared for reporting what they did, but nonetheless they did so. And I didn't know that much because I'm over in electrical engineering and in systems engineering about the basic physics of gravity. And so I just posed the question because the aircraft sound beyond our science, right? They could do these hairpin turns, you get thrown up against the side of the wall.
Like inertia doesn't exist almost.
Right, right. And so I thought, well, it must be anti-gravity or something like that. So I just posed the question, is anti-gravity possible? And later, as I learned about gravity, then I realized it's artificial gravity. You're actually getting control of it. And so because I didn't know at that point, I jumped over and made friends with one of the gravitational professors who was really good at the University of Pennsylvania. So I kind of made a deal. I want to be you be my mentor, and I was a software engineer, and my employment was I do programming for professors. And so here's the deal: I program for you for free, right? And you just become my mentor. He says, well, I got to throw one more thing into the deal. We have this genius sleeping in the lounge of the physics building. You don't even have a place to stay. He was flunking all his classes. He came in as an undergrad because he didn't attend at all, didn't even show up, right? And he realized this was kind of like an autistic genius.
Right.
He took him under his wing. And he says, and to team up with him, the professor, to do papers on general relativity, advanced papers. I said the kid was so advanced. Right?
Wow.
So, but he needs a place to stay. So I said, "Oh, good." He gave me a roommate. So it was. I remember the day I learned about it was during the oil embargo in '74,
Okay.
and all. I'm in Philadelphia, and I see the line of cars lining up for the gas station. And he trots into me with the big book "Gravitation" by Meisner, Thorne, and Wheeler, like kind of the official book for teaching gravitation theory. And he goes, "Have you seen this?" And he shows me the last 2 chapters of the book that talk about Wheeler's theory of geometric dynamics, Wheeler's theory about the zero point energy.
What?
And that's
I've
what
never
I said.
heard of that.
What
They're
exactly?
hiding it in the last 2
The
chapters, is why.
Right, and I go, I didn't hear of it. I go, what the hey? And he's just, oh yeah, this is known stuff. And I said, wow. And he's quoting huge numbers, huge energy densities, right? Like 10 to the 93rd grams per cubic centimeters, extraordinary things. And Wheeler derived the work. And I said, my eyes lit up. Well, I'll go to the library and look at it. And then I couldn't believe it. It was everything you needed, but it was basically based and derived from combining the equations. This is what Wheeler did. He called it the already unified field theory. And he combined the equations of quantum electrodynamics and the background zero point energy field that had a certain characteristic equation. It had to be a cubic equation to be self-consistent for all of electrodynamics. He just said, well, things can't go to infinity forever on a cubic thing. What happens in real world, real space? He says, when the energy density goes up, it pinches off like a black hole or a wormhole. He coined the word wormhole. And so he wrote the book Geometric Dynamics. And when I looked at my notes, I realized that the original presentation of this was a physical review paper he did in 1957. Right, so it goes way back. I said, whoa, if you just cohere this in any small sense, you have basically limitless energy to warp the fabric of space, warp that, and thus you can steer gravity in the direction you want to go. And you don't feel any inertial stress because it turns out the zero point energy is the basis of inertia and why things are kind of tied to space.
And
so, wow, I said, everything is there in our standard physics, right? So I wanted to do my PhD thesis on, and the deal was I stick with standard references using only standard physics, what's in the library, what's in the journals, and I don't go off to her woo-woo class. Although I listen for clues from the inventors and other things that people stumble across.
It
but
all comes out of the ether one way or another.
Yeah, that's what it was called, the ether. It's in fact, it's the evolution of the ether that occurred, and the history of the ether is actually very fascinating because in the 1800s, it was a fluid theory. There's a substrate, light has to propagate in something. So that's how it started as a postulate. The foundation of electromagnetism, classical electromagnetism. The vocabulary of classical electromagnetism was hydrodynamic vocabulary, sources, sinks, vortices, all that vocabulary that was the model. That was the model.
And didn't Maxwell actually have ether in his original equations, and that it was like written out or hidden?
Everybody did. It wasn't hidden. That was the model of electromagnetism, right? And so the history comes along. Then it comes to 1905, where Einstein introduces special relativity. And one of the amazing stories is, and few people actually know the details of the story, unless you're a physicist and understand history. Why would the classical theory appear to be the ideal theory of everything? It was actually called the Golden Age just before relativity was introduced because it looked like we had everything nailed. Three-dimensional space that's obvious, uniform pace of time that's obvious to our experience, and then what happened? What was it about relativity theory where you're willing to accept the concept of a rubbery space-time? Time's not uniform anymore. It changes depending on you, the observer, and giving up your common sense theory of the underlying fabric of reality. Right. Why in the world would the scientific community jump over to this?
Right, like that's what doesn't make sense to me.
It doesn't make sense, and yet when you hear the answer, it's an astounding answer that made sense to the physics community, because the short answer is it unified electric fields with magnetic fields. It turned out that they were the same thing. They unified. And what was amazing to me, that the magnetic field and everyday currents, like household currents in wires, when they calculate it, the simple calculation, just a DC current, but it just AC is the same idea. That the magnetic field, that the velocity is very slow in a wire, and and do you know how slow it is? That shocked me. So I learned this as an undergrad, just textbook, and I was astounded, and nobody else seemed to be astounded. I'm just looking at a standard thing, right, that everybody readily accepts. The drift velocity in normal circuits is 6 feet per hour. What? That's slow. This is the drift velocity, right? Because there's a lot of resistance, and that makes a magnetic field, right, at that slow a velocity, and that ended up being an actual relativistic effect on the Lorentz transformation. So I'm quoting you standard science from a textbook, my sophomore fields book, right? I went through that derivation 3 times. I was astounded that something so slow could be an actual relativistic effect. And they explain what's happened. So you move relative to it. So if there's a charge out there and you start to move that slow, you would manifest a magnetic field on what you're observing, and that wasn't even moving. You were moving, and it was relative. So this was an astounding result. This is just special relativity. We get into warping space later, 10 years later for general relativity. But the unification, the equations work perfectly. A Lorentz transformation on such a slow velocity. And by the way, you can go derivations up on YouTube. So if you Google derived, relativity derivation of magnetic field from motion, it's so well known, and people, it's this old hat. So I'm astounded because you're hearing this for the first time. Of course, when I saw the textbook, and sure enough, it was like a perfect calculation. That unification of the electric field with the magnetic field matching Maxwell's equations perfectly was so compelling that the scientific community pretty well jumped over and accepted special relativity.
But it's that Maxwell's equations were based off the ether, so it's like, how did they get rid of it, right? Like, it's should have been both simultaneously.
Good question. Well, it turns out in the details, you don't really need to get rid of the ether, but the ether starts to become much more complex, right? A Lorentz invariant ether, the calculations start to become complex. So the throwing away the ether was based on the Michelson-Morley interferometer experiment. So that this was the foundation experiment to make relativity acceptable, or at least throw away the ether. And this was an interferometer. And the idea was, if your Earth is moving fast through space and the ether is static there, you'd feel the wind blow by, and it would affect the propagation of light in the interferometer. And thus, at sea level, you would didn't detect much in the Michelson-Morley experiment.
And it's like I guarantee they set it up there intentionally.
No,
I think.
Well, I'll explain it, right? Where you Dayton Miller, okay, who was the president of the American Physical Society. So he's a heavyweight, happened to be an experimentalist. He worked with Michelson, made an interferometer 10 times larger, 10 times more sensitive, did the experiments at sea level, indeed got the same result, took the apparatus at the top of Mount Wilson, and then they started to see the ether drift type of ether wind. And so what it was, it behaved like you would expect on typical fluid theory. If something moves in the fluid, the section of the fluid right close to the boundary moves with it. So there it would be static. That's at sea level. It looked like you didn't feel wind. So as you go up higher and higher, it starts to slip. And so even a hydrodynamic model would be fitting the experiments on the Michelson and Morley apparatus extensive. And that was it was published in the Foundations of Physics. They really couldn't diss him because he was the president of the American Physical Society. Einstein didn't like this, by the way. They didn't like this result until after he passed away.
Right.
And
apparently
then
his
it kind of
He flew out. He flew out and visited Michelson when he was measuring the speed of light down in there in Southern California. Einstein would come out and visit him there.
Yeah, well,
I was
well.
surprised they were like close friends.
Well, they were because Michelson and Morley were providing the proof that there's no ether wind.
Yeah, they were exactly. That's
But-
what I'm
and
saying.
that's
I
all
think
you
it was
hear.
I think it was a conspiracy that
Well,
way
no,
because
it was the true measurement.
yeah, it was. But
what they
the
didn't.
guy you said that then
Dayton
had a
Miller.
big Dayton Miller had like the more advanced, larger ray that was 10 times more accurate, and that he measured both, so he confirmed Michelson Morley's, but then going up to the mountain and then measuring that, confirming that there is the ether wind. It's like that should have been the new preface, like that should have rewritten things and brought ether confirmed by experimental
Right.
evidence back in.
And
So why
now,
did that happen?
right, because it was extremely difficult to do any calculation anymore, because now we have a complex ether, and you really couldn't do much with electromagnetism. But if you throw it away and just use the Lorentz equations that are from special relativity, the math becomes easy. It was an expedient thing to do to make the calculations tenable.
So
Right.
one of the first, what set the precedent of today, where simple mathematics far outsee or gives more credence than actual experimentation to what we claim to be science, the exact opposite of what it should be.
There you go. The expedience of ease of calculation, and everybody is ignoring this work of Dayton Miller, right? It was kind of like a battle at the time, because you couldn't just dismiss this competent physicist. After all, they did elect him the president of the American Physical Society. So it's a real irony. So I actually learned this in 2002 in an excellent talk that summarized the Dayton Miller work. So even a liquid model type ether, which in a way is still too simplistic compared to what we've learned, in fact, 25 years later. So the history of science is scientific community has ether, and that goes way back to ancient ideas and things like that from and then in science, and Maxwell's really used it. Everybody did. They were all
Tesla,
modeling that
Hughes,
way.
and
Oh yeah, Tesla,
Walter
and then, well, it was the model at the time.
Yeah.
So there was no question. So in 1905, this is expedience of doing the calculation. It's easier if we just ignore it. Then we're seeing the classical calculations work out. We unified electromagnetism in a rather simple and somewhat elegant equations to do it. So it's kind of the elegance of the math is what really turned them on. Yeah, let's keep it simple, right? But it didn't last for long. So the world and the scientific community accepts the ether doesn't exist starting in 1905, but it didn't last long, because when we hit 1930, that ushers in quantum mechanics.
Right.
Right, and then you could just say all hell breaks loose, right? Because you thought that ether was tough as a paradigm. Now that's where the 0-point energy comes in. This is where.
That's what I wanted to talk to you. I wanted to talk to you about quantum tunneling and what you felt about that. I mean, because of the spiral and the barrel and what happens and.
Yes, you came to the right place.
Okay.
We'll cover that. So the problem, why did quantum mechanics even come into existence, right? As we see later, it's got the complexity and everything else that's why all hell broke loose, because talk about bizarre times.
Action at a distance.
And that right. And right. He's talking spooky action at a distance. Well, we'll cover those implications. But the real problem was they couldn't explain an atom, right? if in classical theory, if the charge orbits, right, the
There's no
nucleus,
such thing as a perpetual motion,
yeah,
but this electron is just perpetually orbiting, even
right.
though it's an opposite charge of the center,
Well,
so it
it's
should be attracted into each other.
right. It's supposed to radiate away. It's accelerating around and just radiate down in the nucleus. So the esteemed conclusion of the physics community at the time, nothing should exist, right? And they were stuck with a conundrum because why in the hell are we here if nothing should exist? That's what ushered in quantum mechanics. So they started, the Bohr started to model, well, I made a standing wave, I didn't radiate it away, therefore I created, and now they're doing experiments to justify it. They see the spectrum, they discover the various fields. So it's very, very experimental, the two-slit experiment grounded. So now it evolves them into the new theory of electromagnetism, which is quantum electrodynamics. They said, wow, and this theory evolved to be very, very accurate. So we have, but underpinning everything is the zero point energy, which takes us back to this cubic equation that says the energy density keeps going up and up, and you had to have it that way. It was also Lorentz invariant, fulfilling special relativity. So you could move uniform velocity, anyone can move relative to the 0 point field, and they would always see the same spectrum. But the only form of that function had to be this cubic function for the energy density. So it maintains Lorentz invariance and maintains consistency in equations of quantum electrodynamics. Very successful theory in all, but it's completely accepted by the physics community. Yet it's underpinned by this virtually absurd, seemingly infinite energy in the equation. So that's where Wheeler jumps in and says, well, things can't go to infinity, and because general relativity came along 10 years later, well, he could explain it starting in the 50s. Oh, we pinch it off and we have the wormholes. These are like connections that are in a hyperspace thing, which starts to get us into the concept of a non-local connection, a channel that shortcuts you across space-time. So all these ideas start to enter physics, right? These absurd ideas. And so there's a 25-year gap in the history of science where the ether was agreed to not exist. The empty space is empty. And immediately when the quantum electrodynamics got accepted, we filled the vacuum with a way better and more energetic ether model than just a simple fluid. This model is a turbulent plasma model where energy is entering and leaving, right? And it's sourced because when you pinch off space-time, you're going into a higher dimension. It's sourced from a higher dimension, and it's the orthogonal flux model, all derived by John Wheeler. So to picture this, and most people struggle with higher dimensional concepts. Physicists, same old, same old. They have no trouble at all. And as a kid, I read Flatland, so I was down. Oh yeah, bring it on, right? Higher dimensions. So to picture it, you have to picture a tabletop, right? And pretend you're a Flatlander. And then you can only see across the tabletop, left or right, but you have no awareness of up and down. So imagine a rainstorm coming through orthogonally coming through, and as it comes through in a thin flatland slot where you see a little bit of activity, ooh, flashes of energy, like very microscopic as it's coming through, and it comes through in chaos, right? Doesn't seem to have any order to it because you're seeing a tiny perspective of a uniform flux, which, interesting enough, these flux ideas from hyperspace were kicked around in the 1800s in their theories of charge, right? They had charge enters from higher space. They called it sources and sinks. This was kicked around by the physics community in the 1800s. Sinks. Flux enters our free space and then leaves. Well, one charge would be the source, like the positive charge. The flux comes in, exits through the electron, the negative charge. These type of models were actually kicked around, even on the basic ether theories. And that's why the vocabulary of electromagnetism, right, is hydrodynamic vocabulary. It's a fluid theory vocabulary. So I'm just catching my thought of where we're, the
flat
nature
line.
of this flux, this higher dimensional space. This, nearly everyone, scientists, have struggles to understand this or maintain it because they're not physicists who basically learn these modeling. That's just part of learning physics. And these are ideas that have been kicked around historically. So the only realities are three-dimensional space. So this idea of something of a higher dimension, they don't like it. Things could pop in. Things can pop out.
Right, and
Your Bigfoot or your UFOs
or your
yeah.
plasma orb, right?
There you
Or
go.
consciousness.
Shout out to
and
Hoodoo
stuff.
Now
Tall,
we're
Jurgen
getting
Hess.
into a substrate that is incredibly rich in potential and what could go on, and we don't understand.
Right, and that it's like a high space very high space density and energy density because it's a dimension folding in on itself and out of itself.
Right. For an engineer doing modeling approximations, when something goes to infinity, it means, oh, I lack sufficient dimensionality in my model. I get a singularity, right? It's just from the math. Say, oh, my modeling was inadequate because when I get there, the equations just blow up, and therefore I need more in the model. So what do? They don't like these same things. So they do something called renormalization.
Yeah,
I'll
the
just
vacuum
subtract it
catastrophe,
away.
right? Yeah.
Right, and then left with this net little residue that we
have
call
this insane like 10 to the power of 90 energy that represents everything, but we're just gonna renormalize it. We're gonna act like it's
and then
nothing, right?
it's our little secret. Right? It's gone, right? So that's how you can even do. You can't otherwise you can't do tenable calculations, even infinities, right? And they know that. And so a lot of constraints on making a good theory that's acceptable. It has to be renormalizable, so you're not stuck with absurd infinities. Which when you get infinities as you do mathematical model, it just shows your model's inadequate. You're not
Exactly, right?
you're not capturing
The fact
what's going
that
on.
everything's like they're trying to claim, oh, we know everything. Oh, we have the standard model that works and it's right. But when we're coming up with new stuff and trying to do the calculations, we have to renormalize it down to ignoring everything else that makes up the majority of the energy in the
Right.
equation.
So we're throwing it out, and therefore that doesn't count. And now, so most of the physics community are that way. You're not going to make it very far in physics class if you don't go with it and do the calculations. You have to go along with. And so and people kick around these ideas. I mean, Wheeler certainly did. And then the physics community didn't like it because, man, we're stuck with this anything goes scenario with this energetic substrate. And so we can't calculate with it. We can't really explain the nature of charge with it or stability with it. We just don't know. So it's easier if you're trying to do mathematical modeling, you got to simplify the model. So it's basically in math, it's just a Taylor's expansion, Taylor series, right? You just cut off the terms, right? And just work with tenable number terms. So now you can do a calculation and then do your physics papers, do whatever calculations you want. So it's tenable, meaning I can work with it, make predictions, do the experiments and things like that. And if the experiments don't quite match, no problem. It's just a Taylor series. I bring one more term in and have more flexibility.
As long as the numbers that we manipulate work out, that it's real. But with the experiments that are like the physical stuff that we're doing don't match these numbers, don't worry about that. Right?
No, you fudge it. You add more. You make the theory more flexible, basically. And there is criticism that the problem, why is quantum electrodynamics so perfect, matching everything? Well, you made it so, right? There's I might be chasing a tautology here. I'm just tweaking the parameters to match the experiment. So there is discussions like that in physics where not everybody's happy with that. Certainly discussions on string theory, they're not happy with point particles in the model because that just takes you back at the infinity, right? You can't have a concentration into zero, right? And so the string was the idea is I'll make a distributed entity so it doesn't blow up on a calculation. And so that's why string theory is popular because at least I got their foundation correct. But The real problem it was the quantum mechanics. This is what the real problem was. So we're just talking about zero point energy in a sense. Is somewhat straight up, even if you choose to make models to tap it and things like that. You're not getting to the real issue of quantum mechanics, which is what you brought up, this non-local connectedness and things
And
like that.
how space and time gets involved with that sort of stuff.
Well, I'll hit on that exactly, which is popular right away. So I'll set the backdrop on this. So what happened was Einstein liked the idea of local modeling, common sense stuff, local. So relativity was that way, even though space and time could be somewhat rubbery. At least when I want to affect something over there, something has to go over there and kick it, right? It's that's called local modeling. So nothing can. That's why nothing can exceed the speed of light. Can't influence that way. A very orderly, very common sense thing. And the problem with the equations of quantum mechanics, they were predicting, these correlations in the statistics of it that were non-local. It seems like two things that start out together and drift apart. You make a measurement over here, all of a sudden you're going to affect it over there. The measurement, measuring its counterpart. And Einstein was very quick to pick up on this. So they wrote the paper, Einstein, Rosen, and Podolsky. It was EPR, Einstein, Podolsky, and Rosen, paper that essentially was meant to be kind of like a refutation how absurd quantum mechanics is. It predicted this non-local connectivity between these. And so this is very quick. This paper is 1935, and quantum mechanics was just getting accepted in 1930. Right, so just within 5 years, they were predicting it. And by the way, the other founders of quantum mechanics were indeed bothered by this non-local. That wasn't lost on them that this was part of the prediction of it, and they wrote on it. And I remember a book I was gifted, The Quantum Revelation, had to do with going through the historical papers of the founders and them trying to figure it out. What the heck's going on when you have this, because we're taking ourselves completely out of real reality, right?
Yeah.
That common sense reality, which Einstein hated, right? You got to have that. That's your foundation of your reality. And so basically it was a refuge kind of saying, well, this can't be. But the problem was the two-slit experiment. The various founding experiments were making, indeed, quantum mechanics looks like is really working, and it's predicting it does the stuff. And so there was a prediction regarding can I measure quantitatively do an experiment that measures this non-localness and prove that that's either occurring or not occurring. This is a critical experiment. And they didn't quite know how to do it, I think, until 78. Bell, I was one of the physicists, Bell's theorem. He did the mathematical setup of how you could do the experiment. Right. So now we could actually figure out if we do this experiment this way, you could find out if the problem, based on watching the probabilities as you measure this distant thing. Sorry,
Affecting both
right. Now we could do
perspectives.
the experiment. That was the critical thing. So that was why Bell's breakthrough, a big contribution for Bell's theorem, that allowed the investigation to occur. Right? Is this for real, or was Einstein right? This is crazy, right? So they, and I think it was in 1980, Clauser was the name. It was out of France. They started to do the first experiments, first with light, and then I think other particles. And indeed, with extensive experiments, they proved this non-local connection was indeed real, and that the spooky action at a distance was happening. So if we flash all the way forward to trying to explain this, right? Nowadays, there's something called, and this is very popular right today in physics, ER equals EPR. And those letters stand for Einstein-Rosen for the ER, and Einstein-Rosen derived the wormhole, calculation in general relativity, the wormhole. EPR is this predicting this non-local connectivity. So what they have to model it is a wormhole that's connecting these two distant things across space-time so you have a non-local connection. And the physicists, darn if the physicists aren't, they are taking this seriously. They're pursuing it. It's very difficult calculations and lots of interest today. So all this crazy stuff that sounds like woo-woo, the physicists are doing it. They just hide it behind the mathematics that they're doing it. It's kind of like their little secret of what they're investigating. But they investigate tremendously imaginative models.
Hold up really quick. I have a good idea. I'm about to do the utmost like wrestling. You guys are familiar with wrestling when someone taps in and taps out.
Oh yeah.
I think we
Keep
should
tapping.
spice it up a little bit because this is Teslatech. We're gonna bring in Dr. Yu. He's gonna take my spot. I'm gonna tap him in. We're gonna swap him out, and I think he could spice this up a little bit. I think it's gonna get really
Doctor,
interesting.
you joining?
Welcome, Dr. Yu. But
So-
it's been a pleasure, Morray. I love you. Thank you.
Okay, so I guess I just
No,
met
you're staying. Yeah,
just met Dr. Yu tonight. I'll preface to say that Dr. Yu is trying to make a better model for the ether is what the goal was. So it's completely creative. We're in a sense we're like opposites because I just play by the rules. I say I'm going to stick with the standard literature, and darn if there wasn't enough there to provide all we want for absurd things. And Dr. Yu said, "Oh man, you don't have to make it so complex. There's a better way to look at it." So he made his own model, and so I guess you're on.
Okay. Thank you for having me. Well,
pleasure.
you just gave us a great history lessons, and so I agree with your assumptions. 100%. But I gain this insight is not from the historical study, actually from my child dream, some kind of questions. So when I was at a middle school, first time we started a physics book, and some questions bothering me until even after I get PhD degrees. One is electricity. So how could electricity defined as a flow of a charge, right? So who carries the charge? Electrons. Electrons particles. So it is said electricity is a flow of solid particles inside a solid wire at a fraction of the speed of light. Sometimes 70% the speed light or slower, depends on the conductivity material. I just never could grasp this concept. And also, electricity uses the analogy, water dam, right? The water flow inside of that. So that was the first thing I thought I have a questioning. But the second concept from the middle school is atomic model. This is called the orbital atomic model with the electron orbiting crazily at fraction of the speed of light, constantly, right, around the nucleus. This kind of, for me, there's no difference than called perpetual motion machine. How could a perpetual motion machine, number one, where comes the energy? Keep it going because it always have a drag, interact frictions, and also interact between neighboring. You were losing energy. You mentioned about that one, right? Yeah, you're gonna losing energy, and you radiate. When you have a circular motion, that's acceleration. You radiate the energy. So number one, where does the energy come from? The second thing, how can you keep it equal, keep it stable? We know atomic clock based on the most stable vibration signals of atoms. So atoms supposed to have the most stable structure and so stable natural frequencies. So we use that one as atomic clock, as a precision. How can you have a constant motion, have that one? So, and also gravity. So the gravity is so similar to what is the Coulomb's law. So I said they must have a connected, but then my teacher says no, they are totally different. If you look at their magnitude, gravity is equals to one gravity equals to 0.00036 zeros and then one. So then times of magnetic electromagnetic force, just dramatic, totally is a different league of force. You know what? So I studied the physics, try to solve them. After I got my PhD, started working at NASA for about 10 years, I still don't understand. That's the time I said, okay, we have to get rid of this kind of old paradigm, right? And I started to focus on myself. So just give you a little preview what's going to coming tomorrow on my talk. If you just need three fundamental things, if you get it, you don't have to listen to that one. The first thing is I call the monocharged particle. Say electron is a single negative charged particle, right? Or proton is a positive charge particle, or positron, positive charge, and what's the quarks? Quark is a fractional charged particle. So what my first point is, all these called a monocharged particle does not even exist. What does that mean? They are not exist. What does that mean? They are the constituents, the basic elements of atoms. If these single charged particle cannot exist, so this called the perpetual motion machine or orbital machine atoms cannot exist. That's the direct results. Now, the significance is the quantum mechanics model is built on top of this perpetual motion machine called this orbital atomic model. You remember quantum mechanics, why we call it quantum? So there's a particle, so electrons jumping from orbital to different orbital. We call the principal energy levels, right? And then how they jump cannot continuously cross space and time. No, you cannot do that. If you do that, one becomes a traditional classical physics. So then you will fail. The model will no longer exist. You have to, there's no space, no time, instantly disappeared from a lower energy model orbit and to jump to another orbit with no lags of time and space. This is an incredible idea. So that's how the quantum mechanics model built on top of this perpetual motion model. And the perpetual motion model built on top called the monocharged particle, electron and protons. So if those particles not even exist, so what happens to this atomic model? Does not exist. What happens to quantum mechanics? Nothing correct. The fundamental premise is based on monocharged particle and perpetual motion atom. So you know, so from now on, we don't need to ask any quantum mechanics questions. Awareness is all founded for wrong assumption. The lady who dealt with this, yeah, she just asked about the quantum tunneling, right?
Yeah.
Holy cow! So I thought that that would be already deep into the quantum mechanics. That's a cave, a wrong place, a rabbit hole.
Right.
And then I said, does not exist.
Right. So it's the ether essentially more than.
You mean ether?
Yeah.
Oh, okay. Now, perfect. That's my second point.
Well done.
You see, I'm gonna have 3 points, right? The first point, we discredited the perpetual motion model and the quantum mechanics. The second model, that's where you are talking about. So ether is where I studied light. What's the nature of light? Is light a wave, particle, or wave-particle duality? Is that right? After I studied that one, I started to learn ether, or I call the ion field. It's a magnetic field, has to be exist. Without that one, we won't see light. We won't see electrical field. You know, the electrical field through what? Through this medium. Without this medium, no light propagates and no electric field. You can exert the force on body. And this is the same field. And we communicate non-bodily. This is called cross distance. So you and me, we do not have to, look at or even thousand miles away. If we tuning the same frequency through what the brainwave is a vibration electromagnetic wave, right? So that's why connected. We are connected through this wave propagation. So that's the second point. Is a photon, the particle of light, does not exist. If you want to know light have nothing to do with particle traveling, then what is light? It's oscillation and propagation of electromagnetic wave. So that would require you have a medium, and that medium is an electromagnetic medium. So which a little bit than the concept ether seems like a vacuum have some without a substance somehow have this concept ether, and I was restore it as the physical magnetic particles formed. This is called ion fluid, electromagnetic fluids in this field every space. Does it make sense to you? I believe so.
Well, it's new to me because this is the first time I met you, so it's new.
Wow,
But
wonderful.
I've heard ideas like that.
Yes.
Right. I think the Russian ether models evolved. They called remnant neutrinos. I heard that last night, right? And the Russians have evolved different ether theory, different nucleus theory. While we stayed with the quantum mechanics and the quark theory. So I see. I don't know what you're saying, right?
I'm going to explain this one.
So that's new to me.
Yes, you explained this. So the concept is from Russian. It's called what is the?
That's just, and I just learned.
What's
that
the
from,
name? So
from Bob Greenyer last night.
No,
He
yeah.
did summer.
the name called something related to
Neutrino?
neutrino. Is that
Yeah,
right? Okay.
That was the phrase that. So I'm getting it secondhand because last night at dinner, Bob Greenyer about the Russian evolution of their
Sure.
modeling
Yes.
for the nucleus because they're seeing the transmutation experiments and they're
That's
trying
right.
to explain those.
Yes.
And so this is the gist, and I think Bob also he'll talk about it, I'm sure. He has his own embellishment of this model. It's a
Yes.
very sophisticated fractal type model of the fabric of the ether, and so it's fascinating. But it's basically new information to me. So I can't say that I understand it. I'm just got introduced to the idea.
Yep.
And you said your particle name is Yuan?
Yuan is a
Yuan?
universal particle.
Okay.
Universal fundamental particle. I made the yuan because it's one and only fundamental. I will explain in detail tomorrow night. However, I just want to make a comment that you mentioned about this Russian find that there's ether, but the name has a neutrino. Some things with neutrino based on that concept is a current standard model concept. It's a neutral particle.
And is your particle neutral? No,
You
no
cannot
electron?
you cannot have a neutral particle generate an electromagnetic wave. It has to be charged. It has to be electromagnetic charged particle in order to propagate light. Does that make sense?
Yes, but I see it that there can be the neutral charge, but it's just because it has two standing waves disassociating each other.
Cancellation. Yes.
out of it,
Okay.
yes.
Sure. Yeah. This is you are talking about that is a wave-based explanation.
Yes.
So I will give you is a classical particle-based, is particle and wave-based answer make it much easier. Okay. So I will say, yeah, we do have a so-called neutral particle. I may not name it called a neutral.
Charged particle.
Neutral particle refers to its electromagnetic field. Its field is neutral. But when you close look at, when you attach them close in contact, you find the neutral particle actually made by at least even number, called a double magnetic particle.
Yes.
In opposite direction, cancel each other.
Right, it's oscillation of it.
And then you can have an oscillation, and you have a neutral field in far field, right? But in you close contact, you can still combine together. That's how neutron and the proton can connect to each other. They both are made of magnetic particles, right? So you close together, now magnetic force kick in, instead of cancellation each other.
Yeah. 'cause
So
it's
now-
a wave cancellation.
That's a secret to standard model. Standard model say, hey, we have to use called glue them, strong force, right? Glue them. The name sounds like a very funny, right? We have to glue them.
That's the job, right? Keeping them together.
Yeah. So, and then invented the color charge. We have electric charge and the color charge and mediate what is a glue strong force. Right? None of them exist. So now let me talking about the third point. On the second point, so we bring ether back, right? And the reason what is the current standard of physics say, hey, we do not need ether, we do not need ether, and we have called a quantum wave particle duality explanation. So they use what? Use a double slit experiment and the photoelectric effect experiment to discredit the ether, right? Or to justify called wave particle duality. Because my model now bring ether back, it's called the Yuan field, the real electromagnetic particle form the field, the fluids, the field.
Fabric.
And then we can easily to explain double slit experiment, which I would mention that one, and also photoelastic effect. So I will mention tomorrow. And the last one, the third one is if I say these particles does not exist, so what is really exist for our to make up the universe? Only one particle. You know the name? Probably. Universal particle, muons. Muons. So I call it muon, universal particle, universal fundamental particle, but simply just muon, right?
Now, do you derive a proton or electron from that, or yeah? Tell me more.
Yes.
Regarding how do we get charge from?
How get it? So that's a secret. I believe that's something we missed. Say, how does charge related to the magnetic particle?
I have my engineering
I wanted you
theory on that.
to voice out before I tell you.
So I see it in the different, what are currently called the valence shells of the structure of the atom, but they're just charge and polarization and gravitational fields or structures that come off of it.
You touched all the key words. So my question is, what's the relationship?
So that will go over in part 2 when I bring my board back up. But
Okay. Very intelligent. Okay. There is no called electro charge. We are misidentified magnetic polarity as electrical charge. So negative charge, positive charge. The negative charge is actually just a north pole of the dipolar magnet. The positive, the positive charge is equivalent to north polarity, north pole, the charge, and the negative charge actually represented. You can measure it, right? Positive, negative, man and male and female, yin and yang, is represent south pole of magnet charge. So once you discover that one, now we can completely unify electric with magnetism. You mentioned about James Clerk Maxwell, one of the greatest, right, founding, electrodynamics in modern society. He unified electro and magnetic only in the term, in the relationship, they are diagonal. In the wave,
they're actually parallel.
Yeah, parallel. They are perpendicular. Yes, 90 degrees. He unified that one only to that degree, but he still treated electrical charge as a different magnetic polarity. So that's from Maxwell's first equation.
So, from my understanding of it, it's that the electric charge is only one dimensional, like your mono, where the magnetism is the double dimensional.
Excellent point. That's the point I try to differentiate. So what's the difference? You see, we can unite them, right? But what's the difference between Maxwell's electric charge? Electric charge is radiated from center radiated radially. Infinite become an infinite energy source. That cannot be exist anyway. But that's okay. So it basically is a scalar value. Scalar value. So when you're dealing two negative charge electron, you can say, hey, I can attract each other or repel each other along the center. But if you bring another electron, you will never ever balance them. They become a chaotic system because they dealing with a scalar value without a vector. Vector, you have to, any force has to be a vector in order to be called a force. And this vector is not like you can arbitrarily change the direction. No, once your direction has, you have to maintain that direction. That's how you maintain structure stable, because you control the degree of rotation now. You eliminate the degree of free rotation, so that's why structure becomes stable. If it's just a scalar, you can rotate any way, the charge, two charge, and then when you bring third in, it's a chaotic system. So we know we have no solution. So now if we bring this new muon theory back in, so every single particle is a magnetic particle. You know what happens in magnetic particle? Magnetic particle have a north and the south, it's a vector value. So that's why solar system, you know, solar system, every planet orbits the sun, but they always have a one definitive axis direction, right? They cannot tumbling
on the plane, right? The galactic plane, the solar plane, all of it.
So what force can lock them in place? Gravity cannot do it. So actually solar system, the planet and the impact, and also there's an interaction with solar system interaction with the galaxy, magnetic interaction. If once you understand that there is a magnetic attraction, so you know the force.
Well, with what you're saying, though, that's going to mean that magnetism is faster than the speed of light exponentially and goes across the universe.
Okay, I explained that one.
Coherence.
Yes, you know, yeah, you mentioned about the traveling. I don't know. You're referring is the wave propagation speed, or somehow there's a magnetic particles in motion, right? So the so-called speed of light is called the characteristic speed of the medium. You know, whenever medium transmit a wave, is a vibration of every particle in the medium. Vibration vibrate locally, right? They are not moving; they just vibrate locally, and this local vibration started propagate because what? This elasticity, right? Because of the wave is an elastic wave. And this elastic, where comes the elastic wave? Made by magnetic attraction repulsion. So elasticity arises from magnetic attraction and repulsion interaction. So basically, we have to have a medium, and the medium is a magnetic medium because it interacts magnetic medium. And the speed of light is this medium wave vibration. Every wave have a called characteristic velocity. Is average velocity wave propagation. So that's the speed of light. Of course, in order to make this speed of light, instead of use average wave speed light, so they said, oh, we did extrapolate the value to say, hey, what is if we're assuming there's no freezing at all? So that's estimated called the speed of light.
I had a question on your muon particle, and then you were mentioning it's a magnetic particle,
Yes.
and so there's a magnetic field it has two poles, a north and a
Dipole.
south. It's a dipole magnet. So
That's
it's not
defined. That's defined the axis of vector axis. Yes.
Okay, so that's the basic muon particle is like a magnet, is what we're saying.
Simple
And
way
so
say
and so
magnets.
there's really, and then you if that's the foundational particle, then you would have to derive electric charge.
Yeah,
Like a proton has a positive charge or electron. Do you derive those types of charges from the muon?
Number one, so-called electron negative charge, just a part of muon's south pole.
Part of the what is the last word?
Charge in
South pole.
south
What
pole,
he said.
south pole. But basically, in muon theory, there is nothing called electric charge, non-zero. You can throw it away.
It's monopolar.
Yes, it's all is about the magnetic pole. Yeah.
So if we say have to explain experiments where we observe
Yes.
things charging, right, frictional charging, right, and things like that, and what appears to be, let's say, an electron
Yes.
is actually a muon,
Miniature
muon.
magnet.
And then let's say a proton is the other.
Proton is another magnet too.
Another muon.
Just say made by 1,836
Heavier.
time of electron's mass heavier. Yeah.
Right. And so is it one muon particle for the proton?
No. Oh, now you
I'm trying to
mentioned it.
construct. I'm trying to map it to. Well, we believe there are protons and there are electrons, right? And then you say, if you say no, they don't exist.
don't exist in terms of single charged particle. They
Right.
don't exist.
Then we would have to use your model
Yes.
to make one.
Make one.
Yeah. So I want to make a proton using a muon, and I want to make an electron using or multiple muons. Can you use multiple?
Yes, of
Okay.
course. So yeah, he's asking. So based on your model, how you incorporated the current mass, right?
I'm trying to map us to what we
100%.
know, right? So,
So-
okay, we have these particles we observe, so
Very
we
good.
got to now.
So so I use the simplest way. Say, hey, let's define a 1 unit of muon particle as equivalent to an electron. But the difference is muon is a magnet, right? Have both positive and negative. Electron is so-called a single charge. It does not. You can throw it away. And then you got it. And then proton equivalent to how many muons?
good.
1,836
Muon.
muons make the protons. So proton is a composite material.
Yeah, so I'm having trouble when you said electron is just one pole of the muon magnet, and we throw the other pole away. You said
Not through the way. It is just to say, whenever we say hey, negative charge particle, actually what we measured just one magnetic particles that aligned with the north pole, south pole.
So
When you measure one side, hey, we have a negative charge, right? But actually you measure the whole particle. Particle is magnetic particle. You measure the south pole of that.
And
the charge.
where'd the North Pole go?
On the other side,
Other side.
every single particle.
so it's
Has
like,
both
that's
sides.
the part that's like folding in on itself, sort of.
Well,
thing.
I will show you
that
evidence.
was now you're saying something more sophisticated rather than a dipole sitting there, right? I measure this side, and they say, okay, the electron's this side, and they come over to the other side, and oh, the proton's this side,
Right.
positron's this side, right? Well, why? Well, then I would say, well, it's both. It would be electron-positron pair, which is part of the creation of virtual pair production. So you would have pair production.
Explain.
Pair production built in because the muon is basically both. It's
That's right.
both.
So universe is gonna be
Then if
much
we
simpler.
start to separate them. right,
Oh, that's the problem. And that will be violated. So I will demonstrate why it's not should not have a single charged particle. If you separate, what happens? You get a two half of negative charged particle over there, right? You separate the electron. Can you put the two negative charged particles back? Violated fundamental law, Coulomb's law, like charge repel, right? If you cannot put it back, how could they exist in the first place? But this is only theoretical. I call the logical contradiction. But and then the next one I will show you in in 3 videos. Say, hey, what about the physical evidence? I'm gonna using the plasma ball and to demonstrate. You have millions or billions of the light inside of the plasma ball. So have a lot of electrons there, right? And I will show you every single electron there. They're not repel each other. If you put your hands on there, they're all attracted, form one line, right? So I have that's called the cathode, cathode ray tube. Actually, that was the initial mistake made by say, hey, we have a negative charged particle and positive charge. I will demonstrate. So if you wait for tomorrow, I will have say logical contradictions and evidence against electron attraction. Actually, nobody ever see electron repel. You know the reason? When you have two magnets, they repel, like charges, they rotate. The magnetic moment rotate people, right? Once you rotate, now the opposite charge they attract. So that's why when you look at the plasma ball, lots of lights inside, right? If you put hands on, everything form, all the particles form in one line. How could they attract themselves? They rotate their orientation and they attract.
Okay, that makes sense. I like that.
Okay, I don't want to occupy too much time,
Fair enough.
but I will give you the third piece is if these particles does not exist, what it exists is only one particle, magnetic particle. But people ask me, could the universe have other particles? I will show you why if you do have other particles as a fundamental particles, it cannot form this universe. It can never be seen. That evidence I will leave there alone. But I just wanted to emphasize, once I know what is a fundamental particle, is a magnetic particle, that's where I discovered gravity. That's my initial goal to chasing, treasure solving. Does not even exist. It's all gravity effect is magnetic effect. Can be explained by magnetism, called residual magnetism of a body.
Interesting.
I will leave that with
All
tomorrow.
right, so we are gonna have to see that tomorrow. I'm intrigued.
Come to the talk.
That's what I mean. That's what I mean. So if anyone out there watching this live stream wants to see what Dr. Yu's talking about, you should buy the live stream and the pass for Teslatech, and you can see Dr. Yu's presentation. Morray, you've already presented, correct?
I'm
Or you do
2:30
two-
tomorrow
two-
afternoon.
Okay, so
That's
tomorrow
what I
is
present.
one packed day, and you'll be able to see Morray's as well. And then there's mine that's already recorded and up there, so you can buy now and watch later or whatever. But these beyond intelligent, the world's smartest people, literally sitting with us. It's amazing. All right, so you got any last words for this interview? Or?
The imagination that I'm experiencing here, right? That was one perspective. I'm kind of in a way stuck in old school because I was playing the rules of okay, I'll play in their
You're
model.
Mr. ZPE.
Yeah,
what we just
and
saw.
then there are other models, right? That other people proposed. We touched on what I heard from Bob, but it's new to me as well. And over the years, I've been familiar with lots of different models as people propose the theories of everything or whatever they want to propose. Typically, there'll be some type of substrate in ether of some sort to underpin everything that's going on. And then you let the experiments show the way. So I was not ready to propose one, right? I'm barely struggling with working.
You're the one that works out everyone else.
Yeah, right. Right. I'm saying, my gosh, the one that's already there is overwhelmingly full potential for stuff, new ideas, new energy, all these other things. It's inherent in our current models as well. So in a way, it's kind of overwhelming to have such creativity, like under one conference with a ton of different points of view. So what I do is I look where the similarities are, and then they offer clues to how to converge onto the best ideas. So that's my closing statement.
Okay. Well, appreciate it. It's Thank you, gentlemen, and I guess let's get back to it because the night has kind of just begun. Got all your presentations tomorrow.
Yeah, so
So thank you, Morray, and thank you, Wayne King.